children, I came to see you with another video. See, we have to discuss, to draw the structural formula for the following compounds. These are not unusual to you, they are very easy for you. Let's move on. Methanol. Meth, whenever you hear the word meth, you know the number of carbon atoms. Methanol, so carbon only 1. Methanol, for your knowledge I will draw, this is the formation of methane. So instead of this hydrogen, we have to add what? Hydroxyl ion. So they ask you to write the displayed formula for this, to structural formula for this. So this is the displayed formula. I am drawing this one to make you understand how this would happen. Displayed formula, let's write the structural formula. The number of carbon is 1, hydrogen 1, 2, 3, 4, and number of oxygen is 1. Structural formula. Next one, propanol. Propan, 1-ol, or you, some of you say propanol, right? Prop means whenever you hear the word prop, whenever you hear the word prop, you know it is carbon with 3 atoms, right? This is the displayed formula, right? We have to fill carbon with 4 bonds, right? Propanol. This is the displayed formula, but that's not the answer. We need the structural formula. Let's write the number of carbons. Carbon atoms 3. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Number of oxygen 1 atom. Structural formula. Okay, next one, part B. Name the following compounds. How do you do this? Name the following compounds. I am going to draw the displayed formula to make you understand well. Number of carbons 1, 2, 3, 4. Okay, right. This is one of the alcohol, right? What is your first step? Select the longest carbon chain. Okay, this is my longest carbon chain. I have to start to number it by giving the least value to OH. Okay, let's start 1, 2, 3, 4. Then, how do you say? Carbons with 4 atoms, bute. Butane, it's ugly, right? Butane, 1-ol. You know why we are drawing the hyphens, to separate the number, to highlight the number. Butane 1-ol, or you can say butanol, but it's better, this is the best way to say that, right? Let me clean this. Go to the second part of the question. CH3, CH2, OH. How many number of carbon atoms are here? There are 2. So therefore, we call it eth. See, here bonded with hydrogen. Okay. So eth. We select the longest carbon chain, nothing to worry because it's easy. Ethanol. You may ask teacher, why are you not writing ethanol? No point, because if you change this one, if you keep a mirror here, what will happen? You will see, you will gain the same thing. So therefore, no need of writing numbers here. Just write ethanol, that's quite enough. If you, now I'm telling this, if you are going to write OH bond here, what will happen? If I change the bond, you will get the same diagram, same structural, same displayed formula once again. That is the reason why we are not writing a number here. Okay, right. Next one, write the balanced chemical equation for reaction given below. You see there are two processes, there are two reactions here. Let me say this is reaction 1. Okay, go to reaction 1. In reaction 1, I will take reaction 1 separately from reaction 2. Reaction 2. So reaction 1, I'll take it aside. Reaction 1, what is the process? Glucose to ethanol. Glucose, you know the formula, C6H12O6. Ethanol, CH3 CH3 CH2OH. But I prefer, and I am telling you, do not write like that, because you can at once, you can't take the count. To take the count at once, you better write like this. Carbon 2, okay. Hydrogen, how many? 3, 2, 5, 5, 1, 6. Right. This is reaction 1. Is it balanced? Is it balanced? It's not balanced. What are we going to do now? We have to make it a balanced chemical equation. See what we are going to do. We need oxygen. Right, before that, to balance this one, I am going to write 2 here. 2 into 2, 4. But we have a balance here. Here we have 6, here we have 4. See what will happen? Glucose, we have it. Oh, I'm sorry, I didn't see ethanol. Ethanol. Give me 1 second. Right, ethanol. Ethanol, CH3, CH2, OH. Ethanol, C2, H6 and O. Right, now it's fine. See? Now, how are we going to balance this one? So, tell me what are the remaining portions. Let's write 2 here. 2 into 2, 4. So, we need another 2 carbons here. 2 into 6, 12. Done. here carbon 4, here hydrogen 2 into 6, 12. Oxygen, it has 2, right? 4 plus 2, 6, right? Balance. Hydrogen, here 12, they are also 12. Oxygen, here we have 2. Then see the process. You will get two products. One is ethanol. They did not mention carbon dioxide. If you are not writing carbon dioxide, you can't balance the chemical equation. You will get 2 moles of ethanol by taking 1 mole of glucose with 2 moles of carbon dioxide. This is an extra product. See the balance once again. 2 into 2, 4, 2 into 6, 12, 2, 2 and 2 into 2, 4. Right? Okay. Shall I clean the board? I am going to discuss reaction 2 now. Now in reaction 2, they are starting from what we have gained. So what we have gained is what? Ethanol. We will start from ethanol. C2H6O. Ethanoic acid. CH3COOH. CH3COOH. Instead of writing CH3COOH, I am telling you it's good for you to write C2H4O2. I'm going to clean this. I wanted to show you how it comes. That's why I wrote it. Now I'm going to change it to a structural formula now. So let's write C2H4O2. Now what are you going to do? How are you going to balance this one? What will happen? We have to write oxygen here. You need this is not a simple process. This is like industrial process. Therefore, you have to learn this by heart. Not in this level, but anyway, in in advanced level class, you will learn it, right? To balance oxygen atom, I wrote 2 here without writing O2. Then what is extra here? What is extra here? Now we have carbon 2, okay, hydrogen 4, they are hydrogen 6. Oxygen 3. Then what will happen? Oxygen is not balanced. What are we going to do now? Because we have to think about hydrogen too, because we have 6 and we have 4 here. My dear children, let's write H2O here. See whether it's correct. O, 2 atoms. O, 1 atom, 3. O, 1 atom, 2 O atoms, altogether 3. See, the number of carbon atoms, number of hydrogen atoms, number of oxygen atoms are equal in either sides. Right? Okay, fine. I'm moving on to the next level. Ethanol can be converted to ethene and another product in a single step. Complete the equation given below. It's not that hard, you know it, right? We have two carbon atoms. Here now look at the board. Now we have 2 carbon atoms here, and the other side also we have 2 carbon atoms. At that time, there's nothing to be written for the blank from carbon side. Then what about hydrogen? Hydrogen you have 5, here you have 4. So you have another remainder hydrogen. No, 6. So you have 2 here. 5 and altogether 6. Here we have 2. Then oxygen. You subtracted. This is a simple part of this. Move on to the next part. Okay, good question. Crude oil is a complex mixture of hydrocarbons. True. The diagram shows the separation of crude oil into simpler mixtures called fractions. Okay. In the other question they will ask what is X, Y and Z. Z they have given bitumen, no problem at all. X, Y, X is what? Hope you can remember this one. We were discussing this in the classroom. X is gasoline. X is gasoline. How to spell? Y, diesel. In some places they use diesel oil, or some places they say diesel, no problem, both same. Right? Look at the process. Whenever we talk about this simpler, what we call the fractionation, on the top of this diagram, or the top of this process has low temperature. When it goes down, it has high temperature like 400 degrees Celsius. See the way it comes. Right. Okay children, now we are moving to the next part of the question. What could be X, Y and Z? Right? Z is no more there in the diagram because they have mentioned it accidentally, right? And you are lucky. Right? X we have talked, it's gasoline, and Y diesel. Second one, state the use for the refinery gas fraction. You know, because of this the vehicles are on the road are moving due to this. So the use is to get the fuel. FUEL. Right. Now let's move to the next part of the assignment. Name the liquid that leaves a fractioning column at the lowest temperature. You see on the top of this it's 40 and it's what you call below, or the bottom it's 400 degrees Celsius. This C should be here. Okay. So as you see, which one leaves the what you call the column early? It's bitumen. Number 4, one of the hydrocarbons, pentadecane, they have given you the formula, used as a fuel in jet engines. We say superpetrol. Write an equation for the incomplete combustion. This is not the word, we have to use combustion. This is wrong, right? It's a printing mistake. Combustion. Let's write, whenever you hear incomplete combustion, the product is always carbon monoxide, right? It means scarcity of oxygen, or the deficiency of oxygen leads to this. So let's write pentadecane C15 H32 with oxygen gives you what? Carbon monoxide and water. Let's balance this. How many number of carbon atoms should be here? Here 15. So therefore I wrote here 15. So let's balance hydrogen 32. 32 divisible by 2. You will receive 16. Let's try to balance oxygen. Here we have 15 oxygen plus 16. Isn't it? Yes, we have 15, 16, yes, altogether 31. So, right. Hope you understand it. Okay, the next part of this, another diagram, which two are reacting in this experiment? Which two are reacting? As you see, calcium and what? Cold water. So which two parts? You can write in letters, or you can use the formula, calcium and cold water. It's better if you are mentioning cold water because we have warm water too. In the next part of the question, do calcium granules sink in water? Yes, they have a definite mass, therefore yes. Yes. Move on to the next part. What can you see around the calcium granules? What can you see? You can't see this properly because of the color. See, these bubbles are there. Hope you can see the bubbles. Let me draw in blue. These are the bubbles. Right. What can you see around the calcium granules? What can you see? Bubbles of, you can say bubbles, air bubbles. What could be the results that you found in part 3? What could be the results that you found in part 3? What could be the result? So, what do you think? Cold water and calcium reacted? You will find calcium hydroxide. It's not nice. I will clean it, erase it. Calcium hydroxide. I will write the balance equation as it is in the next part of the question. Okay, the next one. How do you recognize the product that formed in fourth one? How do you recognize this? Because this solution turns to a colorless, turns to a colorless solution. What kind of chemical reaction take place here? Let's write calcium solid state with cold water. What could be the result? Calcium hydroxide plus hydrogen. Let's balance this one. 4 hydrogen atoms, oxygen 2, calcium 1. Okay. This is a gas. This can be a solid or aqueous. It depends. Okay, children. Seventh part of this. Write the balanced chemical equation for the above reaction. Did we balance it? Yes, we balance it. Right? In the previous question we wrote the equation and we have balanced it. Right? And the last part of this, name the two products that could be gained. Shall I rewrite the equation? Yes. I'll go back and see. We have cold water. Okay. This is the equation. Okay, this one. Calcium in solid state with cold water, liquid water, gives you calcium hydroxide. Sometimes its physical states can be solid or aqueous. It depends. I told you that. And you have hydrogen gas. We wrote 2 in front of this. Here you have 2, here 2. Right? Write the balanced chemical equation for the above reaction. Okay, done. Now we have balanced it. See, we have balanced here. Name the 2 products that could be gained from the experiment. So what are the 2 products? One is calcium hydroxide and the other one is hydrogen gas. Write the physical states of the products. We wrote it. Calcium hydroxide can be a solid or in aqueous form. Hydrogen, it's a gas. Last one, what could be the color of the foam solution? I told you first of all it turns to a colorless solution. Now it turns to white. It turns to white. Okay. Okay, I hope you understood what we have discussed. These are not new things, we have discussed actually many times, but this is, we are practicing for our exam. Please keep in touch, please keep in practice, and this is the end of the lesson. I'll see you in another video. So stay safe. Okay, bye children, and God bless you.